some study flow data. So let's open the project. Your name should be something similar on the CD. And now we are not seeing anything. No, we need to turn it on there. Okay, so let's put our plan data. We go to this guide finding here, perform on a steady flow simulation. Let's do geometry preprocessor, the simulation itself, the post-processor. And here it is important to tick the floodplain mapping. So we select basically almost all of them, but the segment one. Let's use the same start that we have been using so far. So 26th of September of 2017. Okay. Let's make the computational interval 2 minutes and all the other settings at half an hour. Everything set. So let's save our plan. Ours, remember to save. File. Save plan. Okay. 1D, 2D. Okay. And compute. This one, as there is a grid, is probably take a little bit more of time to run, depending on how fast is the computer. To look at the results in 2D simulations, the best way to do it is through the HEC-RAS mapper. So we go to the HEC-RAS mapper and we see that this entire results field appeared. So I will just include also my geometry. I will untick these storage areas because we don't need it anymore. Okay. And I will also include the 2D grid. So now ticking the results. Yeah, you can also include the geometry here, the results for the 1D. Here we have depth, velocity, and water surface elevation. So if we start with depth, and we click play, we can see how water flowed in the river and what's in the entire area. And what's most important that we see here is that the water didn't go to the area. And the reason why you see these spaces here is because although it's computed 1D, in the RAS mapper, it's going to use the DM. So it's very important that you know that here it's not that the channel is dry or something like that. This is pure visualization in the RAS mapper. If you go to your results in tables and other means, in the 1D part, it's going to be all perfect. So if you go, for example, here in the profile, you see that you have water in the full river, and that's where you get your full visualization of the 1D part, okay? And what happened is that we didn't set this structure to bridge, as we did the last class. So let's add the bridge data in this lateral structure, and then we will see the flow in the 2D area, okay? So let's go to the geometry. Lateral structure. Okay. So I closed the result, the RAS mapper. I went to geometry data. In geometry data, lateral structure. This was the cross section of the lateral structure, sorry, that we were reaching. So reach this structure. We want the water to go. And let's take the data from this spreadsheet. Which is this one.
I think.
You saw yesterday about the progression, right? So this is the window that tells you how fast you want your bridge to happen. So if you were saying that it's gonna bridge in a certain amount of time, then or you set the time for it to start, then you can say how fast it's going. But we are not changing that setting. It's just for you to see that you can set how slow and how fast your bridge is gonna happen. So we set all this up. We can close it.
Okay.
Okay. Everything set. Everybody set the bridge. Yeah, it's missing a 2 there. Yeah. Thank you. So it's going to take 2 times to form the bridge. And here you can set if you want it to be very slow and then fast, or very fast and then slow, and this sort of things. But let's leave it like that, okay? Close this one. File save geometry data. So our bridge is still there, right? Yes. And we can always check if the bridge is still there when running the model because it says that something is going to be reached. And now we go back to our unsteady flow analysis. So you see here, one Levy with bridge data. I'm confused. So you see how fast this one was now because we already pre-processed our data. The tables are already there. We didn't need to change them. Everybody's good?
Yes.
No? It's 945. 945. So now we see some flooding, right? And in a very cool animation. So we can estimate inside these half hours intervals in which half an hour it started to overflow. So it started between 3 and 3:30 in the afternoon. So we can see here, this is the time, okay? So we can see that at 3:30 we have already some inundation. At 3 there was none. So that's the time it started to happen. More than depth data, you can also check the maximum depth. So here we have the maximum, minimum. And it's very interesting that although the structure is reaching here, it's flooding all the way to this part that is lower. So if we take out our depth, we can see from the terrain that this is indeed the lower part. And as a manager, you can take many conclusions from this. Of course, a deeper analysis is needed, but protecting only in the immediate zone was not enough for this area. If you reach here, you already put this region in danger, and a lot of danger because you see how deep the water goes. We can also check the velocity, and the velocity you can also animate it. And one thing I also didn't say about this simulation, but I think it's also important to say, is that if you click in the maximum depth or maximum velocity, you should always check if your 2D grid extends to cover your entire flood extent. Otherwise, this is going to act as a wall, and you are going to get erroneous extent and erroneous depth, because the water that should accumulate, let's say, in this area, for example, where it touches, is accumulating inside the grid, and then you have wrong depths. So please be sure. Here we see that it's a very well defined region. In most of it, maybe here I would need to extend a little more. And of course, in this area that we didn't do because of time. But please make sure when you're doing 2D grids to extend it far enough so you capture the entire flood extent. And in the velocities, you can also include this static velocity error, so it shows also the this direction. Zero. So the velocities are very low. What is the scale of this? It's in this cubic feet per second. So okay, and what else we can get from this kind of visualization? What if I want to know the depth exactly in the middle? Let's say my house is there and I really want to know, or let's be more managers. Let's say there is a hospital here in the middle. I have the coordinates for the hospital and I want to know how deep it would be underwater if that structure reached. You can right click, time series plot, depth. And here you see the progression and what would be exactly the height. So in this case, 10.7 feet. You can also get the values in a table. So I will do it again. You right click and time series plot. And that. Yes? It's not. Yes. No. Even if you don't have the water, it depends. It's not flooding. Did you select did you tick the bridge? Because it looks yours is not bridge. Yes, structures. And you need to tick it here. So here you can see the time series. For you can also see velocity and water surface elevation. You just need to allow it here, okay? So if you also want to see the velocity graph, from this table you can just copy paste everything if you want. The best way for you to get a specific location is if you indeed have some shapefile you can put on top, and then you are sure about the location of the you want to check. And another interesting thing you can do here is to add a profile line. So you're clicking add one, and you can draw it. So let's say there is a road here, and I want to see how is the depth in this road, how would be. And you double click and save. You give it a name, road. What did you say? So you go to this profile line, you click the draw, it's this plus, you click, and then you click again if you want to keep drawing. And when you are done, you double click. You can see the length or you can save it. And you give it a name, road 2. Okay. And when you select one of them, and you stop drawing. So you go to the mouse, okay, and you right click it. Let me just select it. Here, profile line, plots. So I selected this road, plot, and you can also plot that, and water surface elevation and velocity. This will always start from the point that you start drawing to the point you end drawing. So always remember where did you start and where did you finish when drawing these profile lines. And you can check then what is the dead on the road in that line. What would it be in case of flooding for that specific moment. So in this case, I'm getting it for the maps, and then you can keep changing it for different time steps if you wish. Okay? And you can also get a table from this. This is the default set parameters. You can also manage, right click, manage all map layers. Oh, sorry, not here. Manage, right-clicking results, manage results map. So these are the ones that are active. You can add a new map. So here you can add a new map, and this new map can be also the flow in the 1D part, and other properties like shear stress, only the inundation boundary. You can select a very specific moment in time, and it's in this same window that you can export your data. So instead of generating for the current view, that is for the RAS mapper, you can store it as a raster. So raster based on the terrain, it means that it will calculate the depth based on the DM you are providing. And as a point or as a polygon, as we mentioned before, point for certain points in the terrain and so on. It's going to save the map in GOT. So this is how you get the maximum or the profile, your data saved outside HEC-RAS. And as I mentioned before, all your 1D data is also available in the other visualization windows. So here you can also see your profile changing, the bridge happening, and the water going to the area for this bridge. Okay. So, do you have any questions? I have a problem. From the downloads, so it should be in your downloads or wherever it was saved. Let me do a copy and put it in your desktop, RAS examples, and it should be here in RAS examples, Moose, it should be data 2D. Okay? So put it in RAS examples in the desktop. Copy paste there. And then For the ones that copied and pasted from the download folder to the multi data folder, to the RAS examples folder, right click, and some of you have WinRAR, so extract to multi data 2. And those that don't have WinRAR, you can use the 7-zip that comes in those computers. So let me check what's written. 7-zip, so you go to 7-zip, right click, then 7-zip, and then extract to multi data 2. Okay? So I'm gonna write it down there. Extract to multi-data 2. Okay, so right click, and then 7-zip, and then extract to multi-data 2. And you should now have in that folder multi-data and multi-data 2, okay? Is anybody having any problem with that? Now you have the data, you should in your files be able to see RAS examples. I didn't do it yet. So you should be able to see multi-data and multi-data 2. Let's go to our HEC-RAS and create a new project. Now what we are going to do is the same multi-river, but entirely 2D. Okay? So file, new project,